All right. Good day once again. It's Ishola Dedeji Mike, and I welcome once again to Success Enlightenment. All right. In the earlier discussion, we discussed probability distribution, where we are able to illustrate it with two basic examples. But it's also of importance for us to know that probability distribution is classified into two. There are two basic types of probability distribution. We have the discrete probability distribution, and we have the continuous probability distribution. All right, this taxonomy of probability distribution is based on the nature of the random variable of concern. Right, talking about random variable, we already explained what a random variable is, and we're talking about the discrete, just as the name it. If you look at the measuring variable measurement, you will realize that there's certain variable that take finite value, and there are certain variable that take range of what value. This is the major distinction, and this is what brought about the classification of the probability distribution. Right, so without much verbosity, let's get into a discussion of a discrete probability distribution. All right, let's talk about discrete probability distribution. A discrete probability distribution, right? The best way to understand the discrete probability distribution is to actually examine the probabilities of this distribution. All right, a discrete probability distribution. This is a probability distribution that is you focus on the analysis of what discrete variables. A discrete variable. We can clearly define this as a probability distribution that describes the probabilities associated with discrete random what variables, because this is probability, and as far as probability is concerned, we are concerned with variables which result is determined through a what random what experiment. But what is important in this discrete probability distribution is that the value, this outcome, the value that is determined through this random experiment are such that they are specific and distinct in what in value. Right, a discrete probability distribution describes the probability of each possible outcome in a finite set of what outcome. A typical example of a discrete probability distribution include the probability distribution of rolling a fair die. Right, fair, a die has what six sides. When you roll it, right, that is a discrete probability distribution, because you can either show a one, two, three, four, five, or six. Another example is the tossing of coin. Right, if you toss a coin, you can either have a head or a tail. So any probability experiment, any random experiment that gives you a specific value, a vinning set of value, and the value is not in range, that is a what a discrete what probability distribution. All right, without being understood, we still have to go further and state the essential what property of a discrete probability distribution. All right, it's very important for us to for us as students of statistics to have this property at the back of our mind almost all the time, because this is what really make the clear distinction between the discrete probability distribution and the continuous probability distribution. All right, now three basic property of a discrete probability distribution is: one, the set of possible outcome in a discrete probability distribution is what is finite, that is, it is countable. Right, it doesn't take a range of value. Take for instance the scenario of a die that we discussed about. If you throw a die, it's either a one show up, two show up, three show up, four show up, five show up, six show up. You cannot have 4.1, you cannot have 5.2, you cannot have 1.3. All right, it has to have a what a finite outcome, and that's what makes this what a discrete probability what distribution. It has to have a finite what outcome. Another important property of a discrete probability distribution is that what the probability is non-negative. That is, the non-negativity property of what probability. That is, the probability can be zero. Like if it is zero, it means nothing has happened. Like if you throw a die and a three shows up, and they ask you what's the probability that, all right, you throw a dart have six-sided, all right, 1 to 6, and they show you what's the probability that a 7 will show up. All right, that is definitely what is zero because 7 is not possible when you are throwing a die, because 7 is not even part of the possible outcome that can ever occur. So the probability assigned to a discrete probability distribution is from 0 upward. All right, that's the second property. And the last property is what? The sum of all the probabilities of the outcome must be equals to 1. All right, the probability of 1 showing up in a six-sided dice will be what? 1 over 6. The probability of a 2 will be 1 over 2, 1 over 6. Probability of a 3 will be 1 over 6. Probability of a 4 will be 1 over 6. Probability of a 5 will be 1 over 6. And probability of 6 will be 1 over 6. When you sum all the total of all this probability of all the possible outcome, you are going to get what? 1, which means that in every experiment of throwing a die, for a fact, at least one of these outcome will show up. It is a certainty. When they tell you that probability of something is 1, it means that thing occurring is what? Is a certainty. All right, these probabilities these properties are very, very important, and students of statistics should try all they could to actually have this in the back of their mind all the time. All right, with that being said, all right, with that being said, we have to talk about the forms of the discrete probability distribution, because our further focus will be on the discussion of these forms. We are going to be taking each of these forms one after the other. All right, the form of a discrete probability distribution, we have a binomial distribution. All right, we have a Poisson distribution, we have Bernoulli distribution, we have geometric distribution, we have hypergeometric distribution, we have uniform distribution, and we have negative binomial distribution. These are 7 forms of what? Of a discrete probability distribution. All right, each of these 7 give us are easy to use what? Formula and understanding to calculate the what? Probability distribution of a discrete random what? Variable. All right, but before we get into discussing each of these form of a discrete probability distribution one after the other, all right, let's really spice this discussion up and make it juicy by actually solve a real world problem on a what? On a discrete what? Probability distribution. This will be the third problem we'll be solving in this discussion of probability distribution. Don't forget, this is a second video. If you've not seen the first one, please go there and start there. Don't just get into this. All right, the first earlier what I discussed then was what is probability distribution on its own. All right, that's the first, that was my first discussion. So now we're discussing a type of probability distribution, which is a discrete probability distribution. Another type of probability distribution, as I said earlier, is a continuous what? Probability distribution. All right, now this is a question we have. We said if a coin is tossed 4 times, if a coin is tossed 4 times, and y is the random variable of the number of tails obtained. Now find the probability distribution of y. All right, now I told you when you are solving any problem involving what? Probability distribution. All right, the first thing you have to catch up is what is the random what? Experiment. In this scenario, the random experiment is the what? Is the tossing of coin 4 successive time. All right, 4 successive time. So the first thing we have to do here is we have to conduct that actual experiment of tossing the coin 4 times. And after tossing it 4 times, which outcome are we of interest? The outcome we are of interest here is the what? Is the occurrence of what? Of taste. That's the outcome of what? Of interest. How many times does taste shows up? That's what we really want to know in this word, in this scenario. So without much of verbosity, let's just succinctly go straight into what? Into solving this problem, as I demonstrate how in any form they give you anything related to this and you're asked to form a probability distribution for it. This clearly the experiment, once you hear the coin is being tossed and the finished outcome is occurring, that's what makes this what? A discrete probability distribution. So let's get into solving the question right. The experiment we are dealing with is the probability of getting our taste from the random experiment of tossing a coin 4 times. All right, so I said you, when you have any question related to probability, the first thing you do is what? You condone the random experiment itself. So let's just go ahead, let's do our random experiment here. All right, let's go ahead and do our random experiment. All right, okay. So now if we toss a die once, let's say the die, let's say if you toss the die once, so definitely we are certain to get only two outcome from the toss of a die, and that's going to be an head and an tail. All right. Let's say we toss two coin. Rather, you're talking about coin here. Let's say we toss two coin. So if you toss two coin, we could get a head tail from a coin, and we could get a what, a head and a tail again from the other coin. Right. This is our second try. All right. This is our second try. Now don't forget we are asked to toss it how many times? Four times. All right. So the third time, let's go on. The third time we have head, we have tail, we have head, we have tail, we have head, we have tail, we have head, we have tail. All right. This is the third outcome from a random what, experiment. Now for the fourth time, let's toss the coin. What do we have? All right. We have head, we have tail, 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 we have head, we have tail. All right. Now we've successfully conduct our what, our random what, experiment. We have tossed this coin four successive what time. Now what we now need to do is what, is to list all the possible outcome from this random experiment. All right. The first thing we have here, we can have head, 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 head. Like this, we have four heads together. We have head, head, head. All right. We can have head, 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 tail. All right, this is from the experiment here. This is from the experiment here. We can have head, 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 tail. All right, also we can have head, 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 tail, head. We can have head, head, tail, tail. Okay. Also, we can have what, head, tail, head, head. We can have head, tail, head, tail. All right. Okay, we can have head, tail, tail, head. We can have head, tail, tail, tail. All right. We can have now. We can have tail, head, head, head. We can have tail, head, head, tail. We can have tail, head, tail, head. We can have tail, head, tail, tail. We can have tail, tail, head, head. We can have tail, tail, head, tail. We can have tail, 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 head. We can have tail, 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 tail. All right. If you count all these total outcome from this our random experiment, let's do the counting. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now we have a total of what? 16. This tells us that each of these outcome has a probability of 1 over 16 of what? Of showing up in the what? In the experiment. But this is not our point of concern. What's our point of concern is what? How many possible tail can we have? Right? Because the outcome we are dealing with from our question is what? Is the number of what? Tail. All right. So the outcome of tail, we see head, head, head. We can have what? Is zero tail. All right. We can have one tail. We can also have two tail. We can have three tail, and we can have four tail. All right. So the possible number of tails we can have in this our experiment, your random experiment, is either we have zero tail, we have one tail, we have two tail, we have three tail, or we have four tail. All right. So now that we have this, so what we go on from here is what we are going to construct a what a discrete probability distribution what table from here. We are going to construct a discrete probability distribution table from here. All right, to construct your discrete probability distribution table, don't forget, I always tell you, make sure your label is always labeled. It's very, very important. All right, I might think it is not, but trust me, it makes your work. It makes your work professional. All right, write it discrete probability table of the words of tossing a coin four times, showing each successive outcome of tail. All right. So now I will say, let's use y as the question give us. Y to capital letter Y to denote what number of tail, and small letter y should be the probability of what of the occurrence of tail. All right. Now from what we did, we see it is possible that we have a zero number of tail, one number of tail, two number of tail, three number of tail, and four number of tail. Okay. All right. Now from our experiment, there is only one occurrence, one possible occurrence where we have no tail, and that's when we have four heads. When we have head, 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 head. This is the only scenario where we have a zero number of tails. So therefore, the probability that when we toss a coin four times, that no tail will occur will be what? Will be 1/16. Probably 1/16. All right. Now, this 1/16, if you press our calculator, because we can put it in decimal form, we can put it in what? In what? In percentage. All right. You can put it in percentage. You can put it in what? In decimal form. So in this situation, I'll be putting my own in what? In decimal point. 1/16 will give us what? 0. This will be 0.0625. Right. That is 0.0625. That's probability of having a zero tail. Now, what's the probability of having just one tail? What's probability of having just one tail? All right. The probability of having just one tail. Let me clean this up. Let me clean this up so we have space to write that. All right. This 1/16 equals to 0.0625. All right. Probability of having just one tail. We can have head, 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 tail. That's one tail. We can have head, head, tail, head. We can have head, tail, head, head. Then we can have tail, head, head, head. All right. We have four possible scenario of what having what one tail, and total possible outcome is 16. So the probability of having a one tail showing up in the what in the tossing of coin four times, how many tail shows up? One is what will be 4/16. That will be 4/16. All right. That will be 4/16. That will be 4/16. All right. So the probability of one tail showing up is what? Is 4/16. That will be 4/16. And if you press your calculator, you put this in decimal. Remember, I told you you can put yours in percentage. It doesn't really matter. It's still the same thing. So my 4/16 is 0.25. Now, what is the probability of two tail showing up? What's probability that in our experiment we have what? Two tail showing up. Let's my experiment two tail. All right. We have two tail one. We have two tail. We have two tail this two tail, this one, this two, this three, this four, this five, this is six. One, two, three, four, five, six. All right, there are six possible scenarios, possible six possible chances that what two tail will show up in our what in our random what experiment. In our random experiment, there are six possible scenario that two tail will show up, and what we are looking for with the total possible outcome is what is 16. So therefore, the probability of having two tail be what? It be six. It be 6 all over 16. That will be 6 over 16. And you can put this check it once again in your using your calculator. Using your calculator, 6 divided by 16, that will give us 0.375. That's 0.375. Now, what is the probability of having what? Three tail. What's probability of having three tail? All right, let's go back to our random experiment again. Let's see. From our random experiment, how many times do we have what? Three tail. Let's go back once again to our random experiment. Okay, sorry. Let's get back to our random experiment. This is our random experiment. This is our random experiment. And now from a random experiment, how many times do we have three tail? We have one. Okay. Uh, we have one. We have one. We have two. We have three. We have four. So there's only four possible outcome where we have what? Three tail. There's only four possible outcome where we have three tail from our random what? Experiment. So and total possible outcome is what? Is 16. So the probability of having three tail will therefore be what? Uh will be 4 over, that will be 4 over 16. That will be 4 over 16. Which probability will be equals to what? 0.25. All right. So now what's the probability of having what? Four tail. What's the probability of having what? Four tail. All right. From our random experiment, probability of having four tail. There's only one possible outcome where we have four tail. That's when we have tail, 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 tail. So therefore, the probability will be what? 1 over 16, which is equals to what? 0.0625. 0.0625. All right, don't forget the features of what? Of a discrete probability distribution. Number one is what? It has a finite outcome. All right, 0, 1, 2, 3, 4. Those are finite outcome. All right, and also the probability is not negative. In all everything you are finding there, none of it is negative, and the total of all the probability of the possible outcome is equals to 1. When you add 1 over 16 plus 4 over 16, 6 over 16 plus 4 over 16 plus 1 over 16, you are going to get what? 1. So now from here, we can plot our what? Probability distribution graph. This, as it stands here, is the what? Is our probability distribution table. All right, this is our probability distribution table, and if you we can plot our probability distribution graph, probability distribution graph. Let's the probability will be on the y-axis, while the possible outcome will be on what? Will be on the x-axis. On the x-axis. All right, the possible outcome we have 0, we have 1, we have 2, we have 3, we have 4. This is outcome, capital letter y, and this probability should be small letter y. probability probability we have 1 over 16, 2 over 16, 3 over 16, 4 over 16. Okay, 4 over 16. All right. We have to extend our graph further so we can accommodate all the possible value. We have to we have to draw it further so we can accommodate all the possible value. And then let's say this is 5 over 16, and this will be what, 6 over 16. Always make your uh page you are solving, make it spacious so that you don't have to face this problem. All right, so what's probability that the only that is 0 t shows up or no t show? That's what, 1 over 16. That's 1 over 16. That 1 over 16. That's 1 over 16. So okay, that's 1 over 16. So what's the probability that 1 shows up? Probability of that 1 shows up is what? Is 4 over 16. Is 4 over 16. Probability that we have 1 tail, we have, that's 4 over 16. That's 4 over 16. Now what's probability that 3 tails shows up? 3 tails shows up. Sorry, 2 tails shows up rather. That would be 6 over 16. Probability that we have what, 2 tails is what? 6 over 16. 6 over 16. 6 over 16. 6 over 16. Now what's probability that we have 3 tail? Probability that we have 3 tail. Probability that we have 3 tail is what? Is 4 over 16. Is 4 over 16. 3 tail, that will be 4 over 16. And probability that we have 4 tail is again is 1 over 16. 1 over 16. All right, we have to join all these together to form our what? Probability distribution graph. Sorry, that was mistake there. Okay. uh okay, okay, okay. All right, the above graph, this is a what, the our graph of our what, probability distribution. And by this we are done with the question. You are done with the question. The next thing which is important that you should put, don't forget, is what? You have to indicate what this is. All right, you have to indicate what this is. This probability of random variable x. So it's, sorry, here we are using y. Here we are using y. Probability of random variable capital letter y equals to what? Small letter y. All right, so with this we are done with the problem. We are done with the problem. Anything as far as discrete probability is concerned, right? Though there are shortcuts to actually finding this, and that's why we have forms of what? A discrete probability distribution, and which we'll be discussing next. All right, discussing what? The binomial probability distribution. We are discussing the Poisson probability distribution. They are all forms of what? Discrete probability distribution. It's not all the time we have to start drawing tail, head, tail, head, tail. Take for instance, they ask you that the coin is tossed 100 times. I don't think there's any sheet of paper that you can actually use to actually run the what, random what, experiment. So that's where this what, these forms of what, discrete probability distribution, that's where they come in. The formula makes it possible for us to actually find the probability for as big as large as what, as the number of time the random experiment is what, is conducted. All right. All right. That's our succinct brief discussion on what, on the discrete probability distribution. All right. I remember my humble self, Ishola Adedeji Michael, and here is success enlightenment. All right. If this is the first time you coming through this channel and you love what you see, please do me the favor of subscribing to the channel. Gives it a thumbs up, and feel free to express your art. Comment. Let me know how you feel. Let me know if this is helpful at all. Please do that. By doing it, you are doing me the favor, which I'm saying thank you in advance. All right. Next we'll be talking on the what on the special forms of what discrete probability distribution before we go into discussion of the what of the continuous what probability distribution. Till then, I remain my humble self. Once again, this is Ishola Deji Michael. My phone number is always attached to every of my content. Feel free to chat me up. Feel free to call me. Thank you.